Okay, today we're going to do something like this. Okay, suppose you take a sample of students. Let's say there's a very large number of students, like maybe something along this lines. Suppose there's 4 Calc 1 classes, and each one has, let's say, 36 students. Okay, so that would be 144 students, right? So suppose you look at 36 of those students, okay? Let me write this down. Suppose you take a sample of 36 students and find their average test score is, let's say, 68. Okay, so the question is, can you infer what the average test score is for the entire population of students? Based upon knowing the average of a sample, can you infer what the average of the population must be? Okay? The answer is no. Just because you know the average of a sample does not tell you what the average of the whole population can be. Okay? However, what you can do is you can give an interval and say, I'm pretty confident that the average for the entire population will lie somewhere in this interval. Let me write this down. So I'm going to write down exactly what I just said. However, you can give an interval and say we are pretty confident that the population average must lie in this interval. Okay, so let's think of a number line here. So you found the sample average. You took a sample of students and you found their average is 68. Okay, that's an X bar, right? That's a sample average, it's X bar. Okay, and so the question, once again, the question is, somebody asks you, do you know what the population average would be? And again, the answer is no. Just because you know the average of a sample doesn't tell you the average of the population. Now remember, this is just one sample, okay? So I'm not talking about the sample distribution. I'm not talking about the average of averages. I'm not saying that 68 is mu x bar. I'm not saying that. 68 is just the average of one single sample. Okay, so there's no reason to believe that the average of the whole population is the same as the average of one single sample. Okay, but what you can do is you can say, I'll give you a range. Like, let's just say in this case, let's go 4 numbers in each direction. So you could go between 72 and 64. And you could say, I'm pretty confident that the population average, which we call mu, is in this range. So that mu would be between 64 and 72. Okay, a couple of things I need to teach you here. Number one, how do you calculate how wide that range is? That's what I need to teach you. And the other thing is we need to talk about this word right here. Pretty confident. That's not a very scientific word, is it? It's very vague. What do I mean by pretty confident? Okay, so first of all, let's cross out that word because it's too vague. That's not the word we use. Okay, what you do is you give a confidence level as a percentage. You can say, I am, for instance, 90% confident that mu is in this range from 64 to 72. Okay? Or you could say, I am 95% confident if you are more confident. How could you make yourself more confident? By making the range bigger, you see. Or if you want to be super, super, super confident, you could say, I am 99.5% confident that mu is in this range. Okay, and that's called your confidence level. And the range that I've marked in green there, that's called the confidence interval. Okay, so let me show you how to calculate that interval. It doesn't require anything new. It just requires the same stuff we've been using with the normal distribution. Okay, let's start by doing this problem together. Okay, so this is right out of the book on page 338. It says, example 8.1, suppose we're interested in the mean scores on an exam. A random sample of 36 scores is taken and gives a sample mean of 68. Let's highlight that. And also, let's write that down. X bar equals 68. That's our sample mean, okay? In this example, we have the unusual knowledge that the population standard deviation is 3. All right, let's highlight that. What's the population standard deviation called? It's called sigma. So we are told that sigma is 3. And then they give some advice. Do not count on knowing the population parameters outside of textbook examples. Okay, that's fine. Okay, find a confidence interval estimate for the population mean exam score, which is, the population mean is called what? It's called mu. Okay. Now, again, let me just make this clear. We're not going to find out what mu equals. That's just not possible unless we sample the entire population. What we are going to do is we are going to find an interval and say mu is between those two values. But again, we aren't going to be 100% certain. How certain do they want us to be? Well, we don't use the word certain, we use the word confident. Okay. It says find a 90% confidence interval for mu. So let's write under here, let's write CL equals 90%. Okay, so that's what's given to us. Now, how do you do this problem? Okay, like I said, this doesn't require any new material at all. It just requires the same stuff we've been doing for the last week or two. Okay, if you look at a normal distribution, okay, let me draw this here. All right, a normal distribution with an average of 68, x bar equals 68. Okay, this would be a picture of the sampling distribution. Okay, now remember, this is the part that can be confusing. So this is not mu x bar, which would be the average of the averages. This is just x bar, the average of one sample. Okay. All right. Let's write down for a minute here. What's the standard deviation of the sample distribution? The thing we call sigma x bar. I just want to remind you that that is sigma divided by the square root of n, right? Oh, by the way, I forgot to highlight n. Sample size is 36. Let's write that down. N equals 36. Okay, so what would be the standard deviation of our normal distribution here that I've drawn? It would be 3 over the square root of 36, which is 0.5. Okay, all right, now notice that we've used this number and we've used that number and we've also used this number. What's the only thing we haven't used so far is this number. Remember that the area under this whole entire thing is an area of 1. Okay, what we want to do is this. We want to mark off an area of 90% in the center. Okay, so what I'm saying is, let me draw 2 lines down here. I want this area here to be 0.9. Okay, now let me tell you that a lot of books, for the confidence level, a lot of books will call that alpha. So let me put here, let me put alpha. Okay. And let's go ahead and write here in the picture that we want that to be, whoops, we want that to be 0.9. It's 90%. Okay. The question is simply this. What are these two numbers here? It's a very simple question. What are those two numbers? Okay. And then when we find those two numbers, then this, let me make this a little bigger so it's easier to see. This right here, that will be our 90% confidence interval for the population mean. Okay? So do you remember how to find numbers like this? You have to use the idea of a z-score. Okay? And we use the normal, standard, I should say, standard normal distribution. Okay? So let me draw a picture corresponding to that. Okay, where that's 0. Remember, standard normal distribution means a mean of 0 and a standard deviation of 1. Okay, so let me just finish making this picture here. .9. Okay, and we need first of all to find, I don't know what just happened here. Let me see what's going on. Okay, back again. So we need to find these two numbers using either the table in the back of the book or Excel. Okay, now you know from the lectures, I think it's much better to use Excel. But I'll show you one more time how to use the table in the back of the book. For those of you who don't have access to Excel and you need to use the table in the back of the book, I'll remind you how to do that. Okay? Now the key is this. How much area is right here that I'm shading in gray? How much is that? So think about it. The whole area under the curve is 1. The blue shaded part we want to be 0.9. So what's left over is 0.1, right? These two things together here, that and that together make up 0.1. Why? Because the blue part in the center is 0.9. So what's left over? If the blue part is 90%, how much is left over is 10%, right? Which, by the way, I'm sorry about this error. That number 0.1, that's the number we call alpha. We don't call the 90% number alpha, sorry. Alpha is actually what is left over outside of the 90%, okay? Those are called tails. You have a left tail, which I shaded gray, and a right tail, which is still blank, okay? So both tails together is 0.1. So how big is each tail? Take alpha, which is 0.1, and divide it by 2. And that means you would get 0.05, right? 0.1 divided by 2 is 0.05. So that is 0.05, and also that's 0.05. Okay? But we only need to look at the one that I shaded gray, so I'm going to erase that thing I just wrote there. Okay? And let's write it over here. So the number that I'm writing is close to the area in the picture, 0.5. Okay, remember that's alpha over 2. And alpha is 1 minus your confidence level. Okay, so let me show you how to use the table in the back of the book, and then I'll show you once again how to use Excel. Did you notice that I inadvertently, I don't know what I said verbally, but I wrote 0.5, and that wasn't what I had originally said, was it? It was 0.05. So good on you if you caught that error. Sorry about that. Okay, how do I use this table? Okay, now, if you're going to use the table, you do it very differently than you would if you're going to use Excel. So decide beforehand if you're going to use the table or Excel. Okay, because they are used very, very differently. If you're going to use the table, then you must look up that area right there, half of the blue area. So the whole entire blue area is 0.9, right? So what's half of it? Would be 0.45, and then this would be another 0.45, correct? It's this number that we want to look up in the table, okay? In this part of the table, what most people call the body of the table, not the margins, okay? Those numbers in the body of the table are 4-digit numbers, right? So let's write 0.4500, okay? You want to look that up in the table. You won't find it, but come as close as you can. So here, I'm going to zoom in, okay? Here's 0.4495. And here is 0.4505. Our number, 0.4500, is right in the middle between those, right? So here's what we're going to do. Let's look at 0.4495. Go over to the left, and you see the first 2 digits you see is 1.6. So let's just write that down as some scratch work, 1.6, okay, and then go up. This will tell us the second decimal place, which we see is a 4. See how it says 0.004? So add that on to the 1.6 and we will end up with 1.64. Okay, now look at this one, 0.4505. That gives us 1.6, and we add to that 0.05, and we get 1.65. Now, what's halfway between 1.64 and 1.65? It's 1.645, right? So that number, 1.645, is this number right here, 1.645. Okay? And that's a z-score, isn't it? So I'm going to write z equals. Now the book calls that z with a little alpha. And what's alpha in this case? 0.1. So I'm going to write z with a 0.1 down here. Okay? We don't need the table anymore. We're done with the table. Okay, so if that right there is 1.645, then what's this number right there? It would be negative 1.645. All right, excellent. Okay, and so we have this range right here between negative 1.645 and positive 1.645. All we have to do is now transfer that up to here. Now the question is, how do we transfer from the bottom distribution up to the top distribution? Well, to do this one here, here's what you do. That is x bar plus z alpha times sigma over the square root of n. Okay? And this one on the left side, that is x bar minus z alpha times sigma over the square root of n. Let's work those both out. So on the right hand side we would have 68 plus 1.645 times 0.5. We already calculated that 0.5 up above. You see that? Okay, let's pull out a calculator here. Let's do 68 plus 1.645 times 0.5. And what I'm getting there is 68.8225. Okay, that's this number. 68.8225. Okay, I'm going to erase that now. If you need to see it again, you can rewind the video. Now let's find that other one. We would have 68 minus 1.645 times 0.5. And that equals 67.1775. So that's this number here. Okay, and we would say we are 90% confident that the population mean is between 67.1775 and 68.8225. And it doesn't matter if you use strict inequality here or if you say less than or equal to. That part doesn't matter. You can say less than or less than or equal to. The book puts the equal to, so I'll do that. Okay? Or you could say this. You could say our 90% confidence interval for mu is the interval from 67.1775 to 68.8225. And again, here it wouldn't matter if you put square brackets or parentheses. Okay, so that's how you do confidence intervals. Now I did that using the table in the book, right? Let's do the same problem. We're not going to start all over, just the last little bit, using Excel. I think that's much easier myself, and I think you get also a more precise answer. It's a win-win situation. It's easier and you get a better answer. So let's just go right back to, again, we don't have to go very far back. We're just going to go back to the part where we're going to find these numbers here. Okay, all I have to do is go into Excel and type this equals norm dot s dot dist, sorry, not dist, not this time, because we're not trying to find the area, we're trying to find the z-score. So this time it's dot inv, which stands for inverse. Okay, and then you put in parentheses our number that we were talking about earlier right there, 0.05. So let me type that into Excel right now and tell you exactly what it told me. It gave me this number. It gave me negative 1.64485. So that's this number right here, negative 1.64485, which means this number on the right is positive 1.6445, and that is the number that we call z with a little alpha. And alpha is 1 minus the confidence level. So in our case, alpha is 0.1. Okay? So see, it's a lot easier just typing this into Excel. That's all we had to do instead of looking things up on that table. Much easier. Okay, and now this part is going to be exactly the same. Then we want to transfer up to here. So we do x bar plus alpha, z alpha times sigma over the square root of n. So that's 68 plus 1.6445 times 0.5, and we get $68.82225. You don't necessarily have to write down six decimal places, but I'll go ahead here and write down all 6 decimal places. Okay, And now let's do this one. For that one, you do x bar minus the same number. Okay, so 68 minus, it's the same calculation, just changing the plus to a minus. And we get 67.177575. 67.177575. Okay, so that's our confidence interval. We say the 90% confidence interval for mu is the interval from 67.177575 to 68.822425. Or we can say we are 90% confident that mu is between 67.177575 and 68.822425. Okay, that's how confidence intervals work. It's going to take some getting used to, but it's not hard to do once you get used to it, okay? Now let's look at another example. It's going to be the same question, except to change the confidence level. Okay, look at example 8.2. It says do the same problem, except now use a 95% confidence level. So, you see where I wrote the confidence level there in gray before? Okay, I erased it, and now I'm going to change that to 95%. Okay, so what does that mean? That means we want this area to be 0.95 this time. So, what is the gray shaded tail area? Okay, so alpha equals 1 minus 0.95, which is 0.05. So alpha divided in half is 0.025. Okay. I go to Excel and I type in equals norm dot s dot env parentheses 0.025, and it gives me the number negative 1.95996. That number goes right here, negative 1.95996. The other side is positive 1.95996. Okay, that is your Z with a subscript of 0.05. That's your Z alpha. Okay. And then up here we do 68 plus 1.95996 times this number right there, 0.5. And on the other side, we do 68 minus 1.95996 times 0.5. Okay, take out a calculator, type that in. one on the left is 67.02002. And the one on the right is 68.97998. So we can say we are 95% confident that the population mean is between those two numbers. Okay? If you want your confidence level to go up, then the interval is going to get bigger. And if you want the interval to get smaller, then your confidence level is going to go down. Okay?